Welcome to Curie Electronics. This is the second part of URSC 2019 Technical Assistant Electronics question paper solution. Let's move to the question. Question number 31. Barkhausen criteria for oscillation is. The answer is option A. To get proper oscillation, the gain multiplied by the feedback factor should be equal to 1. Now let's see what happens if A beta is greater than 1. Then the oscillation starts, and what happens? The clipping occurs. It's not square, but on the top the clipping occurs. So the output of the oscillator is distorted. This is what happens. This is a clipping occurs in the oscillator. If the output of the if A beta is greater than 1, we will get clipping. Let's consider A beta less than 1. Then what happens? So the oscillation starts. It's a proper same frequency oscillation. Due to my drawing, it is like. Then what happens after it dies down? See, the amplitude decreases and the oscillation dies down if the feedback factor multiplied by the gain is less than 1. So the right answer for the proper oscillation, A beta has to be 1, equal to 1. Second question. In TV transmission, what we do? AM we use for picture and FM for sound. So which is the option? Option A. AM for picture and FM for sound are employed. What is the frequency band of FM? That is 88 megahertz to 108 megahertz. What about AM medium wave? AM medium wave band, that is around 450 kilohertz to, not 450, 535. Sorry. It is around 535 kilohertz to around 1700 kilohertz. That's a medium wave band AM frequency. Binary equivalent of gray code number 0101 is. So gray code, he has given the gray code. What is the gray code? 0101. The gray code, the MSB of the gray code. This question easily you can identify. MSB of gray code equals MSB of binary equivalent. What is the MSB here? This is the MSB, the first from left to first, that is the MSB. The MSB is 0 here. If you see in the answer, we having only one 0. The answer on the option starting only one is 0 starting with. So the answer is option D, simply we can say. But how it is? Now, so I'll write down the MSB, I'll write it down same as 0. Next what I will do, whatever the answer I got, this MSB I will XOR with 1. For an XOR gate, this is the XOR gate. Let it be A, B and Y is the output. A, B, Y is the output. Whenever inputs are same, XOR gate will give output 0. Whenever inputs are different, XOR gate gives high output. So when it's 1, 1, we'll get 0. Now, so if you 0 XOR 1, what do you get? You get 1. Again this 1 we can XOR with XOR with 0. So what it gives? It gives 1. Again this 1 we XOR with this one, input 1, the blue color one. Yellow color one XOR with blue color one. So what we get? We get answer 0. So the right option is option D. A complement or B complement equal to Q. This is just direct De Morgan's equation. What is the De Morgan's? How we can write as per De Morgan's theorem? A complement or B complement. This can be written as AB whole complement. That means it's a what is this AB whole complement? We have two inputs, A and B, and it's complemented. So it's a NAND gate. So answer is option B, NAND gate. Question number 35. In an amplitude modulated system, if the total power is 600 watt and the power in the carrier is 400 watt, then the modulation index is. In AM, the total power varies with modulation index. So what is the equation? Total power in AM PT equal to PC multiplied by 1 plus M square by 2. This is the equation. He has given what is PC, total power, that is 600 watt. So 600 equals PC, what is the carrier power? 400. 1 plus M square by 2 we don't know, we have to find. Now left side of the equation and right side of the equation. So what I do? I cancel these two zeros. Both sides of the equation I will divide by 2. So 2, 3. Now let's open the bracket. So 2 plus we are multiplying with 2, the right side of the equation. 2 plus 2 multiplied by M square upon 2. 2 cancels. This 2 will take it to the left. So what will be there? 1 equals M square. That means we get M equal to plus or minus 1. M equals plus or minus 1. But we will take plus only here. So we have answer option D, 1. So the modulation index equal to 1. So from here you should know what is the total power equation of a AM. Next question number 36. If the minimum range is to be doubled in a radar, the peak power has to be increased by a factor. Let's write what is the range equation of a radar. PT, this is the transmitted power, sigma AE upon 4 pi whole square. At the maximum range, the received signal is minimum, that is S min. S min to the whole power 1 by 4. This is the range equation of a radar. See here, Pt is the transmitted power, sigma is the target area. Target area. Or we can consider aeroplane or whatever it is, wherever the waves hit, that is the target area. And A is the effective area of the receiver. S min is the minimum signal received by the radar. So, the question is asking the relation between the range and the peak power. R max. This we can write it as everything is constant. So what we can do? We can just replace by a constant. Then Pt to the power 1 upon 4. So R max directly proportional to Pt upon 1 by 4. Now in place of Pt, if you put 1, that is the transmitted power. If you increase by 4 times, what happens? We are increasing by 4 times. Then what happens? So 4 R max 4 upon 1 by 4. If you do like this, what we get next is, what do we do? We'll put 16. 16, how we can write? We'll get a 2 to the power 2, we can write it as these 2 here. Okay, now 16, instead of 16 I'll write it as 2 to the power 4 upon 1 by 4. In 4 also we can write, but it is not coming double, it is not increasing. So R max directly proportional to 2 to the power 4. 2 to the power 4 means 16 to the power 1 by 4. And now what happens? R max directly proportional to 4 multiplied by 1 by 4. This 4 cancels. So from here we can see, when we increase the transmission power 16 times, the range increases by 2 times. So the answer is option C is the right answer. Question number 37. In OSI network architecture, the routing is performed by the network layer. We are not going in detail now here. Let's try to do another video. To carry out multiple shift operations in a single clock cycle. Now, right shift means what? The microcontrollers, basic microcontrollers, we have right shift. Right shift means dividing by 2. Right. Now what about left shift? Left shift means multiplication by 2. So if you want to multiply or divide, we should have a number of shift. We have to do number of time shifting. See, right shift 32. Right shift by 2. Okay. If you want to do this operation, we have to use 2 clock pulses. First, when you right shift, you will get 16. Again, when you get again once more, you have to right shift, you will get 8. To avoid that, what is there in the modern processors like ARM? They have got a barrel shift register. What is it? Barrel shift register. barrel shift register. So in a single clock cycle, it can do n bit shifts. That means we can do 2 shifts, 5 shifts, 8 bits, depending upon the number of bits. Usually ARM is 32-bit microcontroller. So 32-bit, we can do up to 32-bit. 32-bit, what the shift, right or left shift, or what kind of shift you need. So it's a barrel shift register. So the answer, to carry out multiple shift operations in a single clock cycle, the modern microprocessor or microcontroller has got barrel shift register. So the answer is option D. Question number 39. How many bits are required to implement a microprocessor having 115 instructions? See, when you are writing microcontroller programming, the manufacturer gives a set of instructions. That instructions depend upon the how many bit microprocessor it is. If it is a 8-bit microprocessor or microcontroller, 8-bit, it can have 2 to the power n instructions, that is 256 instructions. 2 to the power 8 instructions, n is here 8. Now we have 115 instructions, right? So we can have 2 to the power 7. 2 to the power 7 means 128. 2 to the power 7 gives 128, right? So this is sufficient for 115 instructions. Instructions means what? It's a bit pattern. So that when you use that particular bit pattern, the microcontroller understands, or the microprocessor understands what it has to do. So the answer is option C is the right answer. Question number 18. Maximum count value for a n-bit counter is n-bit counter. How many states are there for a n-bit counter? States of n-bit counter. N-bit counter. State means what? Different combinations of bits. See, this will be 2 to the power n. But what is the maximum count value? It will be always 1 less than this states, number of states. Max count value equals 2 to the power n minus 1. If you take so the answer is option A is the right answer. So you take a 3-bit counter, 0, it starts from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, no, 1, 0, 0, 1, 0, 1, 1, 1. See, 8 states are there. 1, 2, 3, 4, 5, 6, 7, 8 states are there. But what is the maximum count value you got? This is 7. So it's a 2 to the power 3 minus 1, right? 8 minus 1. So maximum count value equal to 7. Which of the following is not a microwave generation source? The answer is option B, pin diode. It is used in receivers. Then here, this traveling TWTA means traveling wave tube amplifier. It has got this traveling wave has got a helix structure to match the RF velocity with the electron velocity, helix structure. Then only the energy transfer happens. The magnetron, so magnetron is a different, this magnetron is known as cross field device. These all are microwave generators, klystron, or they say oscillators, microwave oscillators, cross field device. This magnetron is a cross field device. That means electric field and magnetic field are perpendicular to each other in a magnetron. Okay, let's move to the next question. Return type of rand function in C programming is int. In these questions I am not going in deep. I'll try to help you out with a different video. Return type of rand function in C is int. Rand function is used to generate random numbers. In C programming, when fopen is not able to open a given file due to any reason, it returns null. This fopen means file open. To read, to write, or to update a file, first we have to open the file. So for that we have to use fopen in C. That is the command to open the file for updation or reading or writing, anything like that. So if it gives, due to any reason, if it is not able to open, it gives a null answer. Question number 44. In PLC, FRD instruction does the following operation. What does it does? It converts BCD to a decimal. That means it converts BCD to an integer value. Thyristor in a semiconductor device with, what is Thyristor? Thyristor is a PNPN device. PNPN device. We have an anode, we have a cathode, and somewhere here we have a gate. So how many junctions are there? This is the J1, J2, J3. So we have 3 junctions. What actually this Thyristor? This is a LCR. There is the anode, cathode, and the gate. The breakdown voltage in power BJT depends on the drift region thickness. The dominant mode in rectangular waveguide is. These waveguides look like first when I saw, I thought it's a pipe. It looks like pipes, okay? It's a rectangular waveguide. And in this rectangular waveguide, the TE10 mode, the transverse electric TE10 mode is the dominant mode. The dominant mode means what? This one more thing you should know. These waveguides are actually high pass filters. Waveguides are high pass filters. That means they will start from a particular frequency to pass. After that it will pass all the frequencies. High pass filters. And the cutoff frequency. The cutoff frequency, there is a simple equation. Cutoff frequency of the waveguide is given as C upon 2A. This is the simplest equation. There are different equations. C is the velocity of light. What is A? A is this length. This is A. Of the 128-byte internal RAM of the 8051 microcontroller, how many bytes are bit addressable? How many bytes are bit addressable? If we represent, we can represent the RAM like this. RAM. For the basic 8051, how much RAM is there? That is 128 bytes of RAM is there for the basic 8051 microcontroller. And this top 80 bytes. These are this like a scratchpad RAM plus scratchpad plus what is that? That is general purpose. General purpose. This top 80 bytes are used as general purpose registers plus the SFR registers, special function registers, 80 bytes. And now another 16 registers are bit addressable. 16 registers means how many bytes? In 8051 it is like 8-bit microcontroller, so each register is with 8-bit, so it is 16 bytes. 16 bytes of bit addressable memory. So what up now? What else is left? 16. Then there has to be total, we should get 128, right? Now there are 4 register banks are there. Register bank 3, register bank 2, register bank 1, register bank 0, each of 8 bytes. So this totally occupy an area of 4 8s are 32 bytes. R0, R1, when you use those instructions, these register banks are getting used. So now totally 32 plus 16, 48, 48 plus 80, 128 bytes. So the answer is option B is the right answer. 16 bytes are bit addressable. Next question. When 8051 microcontroller is powered up, the stack pointer contains the value 07H. Question number 50. Minimum number of flip-flops required for modulus 16 counter. If you have 4 counter, how many states are there? That means 2 to the power n we will get. N is the number of flip-flops. If we take 4 counters, we can count up to 16. So the answer is option C. Similarly, if we take 3 flip-flops, how many values we can count? What mode counter? It is going to be mod 7 counter. It can count up to 8 states. Question number 51. Which of the following gates can be used for parity generation? Parity generation means we use XOR gate. For parity generation we use XOR gate. Okay. And the parity, what is the parity? Parity is used for error detection. There are 2 different types of parity, even parity, odd parity, and this is used for error detection in digital communication, small distance communication, error detection. But but it can detect only single bit error, but though error correction only single bit error detection. Recursive call in C is recursion means in C, inside a function if we call the same function again and again, that is called recursive call. So the answer is option. Calling a function from inside of the same function. The same function calling the same function inside is known as the recursive call. Question number 53. A trap flag in 8086 is used for. A trap flag. It is in the 8086, this trap flag is used for on-chip debugging. On-chip debugging. On-chip debugging. That means after writing a code, we can, with a debugger software, we can debug the software. So to debug the software, it should execute line by line. So it is a single stepping instruction, single stepping, one line, each line by line this flag execute. This flag is used for on-chip debugging in 8086. It moves line by line, so that is single stepping. It's a VHDL question, VHDL code. Once this VHDL question comes, you read the question. Don't neglect it, don't leave it. Sum equal to A XOR B. Carry equal to A and B. A and B are the inputs represent. What it is? It is, look, once you know the digital logic, you will get an idea. It's a half order. That is, sum is given as A XOR B. A, B. So sum equal to this, A XOR B. Now what is carry? Carry is saying A and B. Carry is A and B. This is carry. So this is a carry is A and B. So it is a half adder. So VHDL code, or just read it, it will be a logical question. So the answer is option A. Kirchhoff current law. What is Kirchhoff current law? This current is I1 is coming in, I2 is going out, I2 going out, again I3 coming in, I4 is leaving the point at a node or point. At this junction, what is happening? The algebraic sum of current is going to be 0. Whatever current coming in, I will take it as negative. That is I1 plus I2, current leaving, I am taking it as positive. Again I3 coming in, minus of I3 plus current I4 is leaving, I4 equal to 0. The algebraic sum of currents. So we can take it either whichever current you are okay, you take it as incoming or outgoing, equal to 0. Equal to 0. So which is the answer, right answer? The algebraic sum of the currents flowing into any point in the circuit must know the option B, the algebraic sum of currents entering and leaving any point in a circuit must be equal to 0. Option B is the right answer. Question number 56. Which of the following is used for impedance inversion in a transmission line? In the answer impedance inversion, we use quarter wave line. It is also known as quarter means lambda by 4 wave line. 57. A power amplifier delivers 25 watt AC power to a 4 ohm speaker load if the DC input power is 40 watt. So P in is what? 40 watt. And it delivers a power output P out, that is 25 watt. Now what is the question? What is the efficiency of the amplifier? So efficiency equal to what? What is the efficiency equation? P out upon P in multiplied by 100. So what is the P out value? 25. 25 upon what is the P in? 40 watt multiplied by 100. Now we can cancel. How do you simplify this quickly? Okay, we can just cancel it. 40, we will try 40. How many times? 5 times. This is 8 times. So 500 upon 8 we get. So 500 upon 8. 6 8s are 48. 20. 2 times. So 62.5. You will get 62.5. So the answer is option. Option C is the right answer. Next question. The input power to a filter is 1 watt and output power is 10 milliwatt. The alternation offered by the filter. Alternation, when alternation comes, and the output power will decrease. Now let's write the power gain. Power gain in dB. Power gain in dB. What is that? What is the equation? 10 log, you see here, 10 log 10 to the base 10. P out upon P in. This is the equation. Now, log 10 to the base 10. What is the P out he has given? Input to the filter is 1 watt. And the output power is 10 milliwatt. So we will write it in watt. 10 upon, if I divide by 1000, the milliwatt converts to watt. What is the input power now? See, this is a single term. I have converted into watt. 10 milliwatt I have converted into watt. And what is the input power? That is 1 watt. Now let's simplify it. So it is 10 log to the base 10. Okay, to the base 10. Don't forget. So his 0 will cancels. This 1 upon 100, I can write it as 10 to the power minus 2. Right. Now, how do you simplify 10 to the power? As per the, I can use the logarithmic property. So, I can write it as minus 2 multiplied by 10 log 10 of 10, which equals minus 20. What is log 10 to the base 10 equal to 1? So it is minus 20 dB. Minus 20 dB. The minus shows the decrease in power. The alternation offered by the filter is the magnitude. So it is 20 dB. In C, when an array is passed as an argument to a function, which of the following gets passed? See, array means what? It is a memory location. See, array means continuously we can save the numbers. See, it may be a 4 byte number. So the base 0, then after 4 bytes, it will be 4, 7, 11. Like this the numbers will be there. So what we will do, we will pass to the function, we will pass the base address of the array. Base address. Here what is there? Here data is stored. 4 byte data is stored. 4 byte data is stored in every memory location. So what do we do? We pass the base address to the function. So the answer is base address of the array. The last question, question number 60. In PLC, SQL instruction in PLC is, the answer is option C. An output instruction and captures reference conditions by manually stepping the machine through its operating sequence. I tried to read about it, but I did not get enough time, so I'm just giving you the answer. You read about it, understand it, and learn about some more important PLC instructions. So I hope these videos are useful to you. If you think so, please share with your friends. Also, I will try to give you the solved question paper in a PDF format. You can get it from the Telegram channel. So please join the Telegram channel. It will be useful to you. So don't forget to hit the like button. So we have completed the 2019 URSC question paper. See you with another question paper solution.